Good afternoon, everybody. This is Joe Drumgoole here, Director of Developer Advocacy at MongoDB. We'd like to welcome you to Webinar 3 in our Back to Basics series. This webinar is called Thinking in Documents, and we're going to talk about how you need to slightly change the way you think about the world you reside in when you start using MongoDB, because it's slightly different to the databases you might have used beforehand. So if I just do a quick review of where we've got to, in Webinar 1, we talked about and introduced the whole idea of NoSQL and talked about the different types of NoSQL database, graphs, wide column stores, and document databases. And of course, MongoDB is a document database. We also went through a little bit about replica sets and shards, which are the two ways in which MongoDB ensures that we keep our data safe and durable, and that we can scale out the load by partitioning the write load across lots of different shards in the database. In Webinar 2, we showed you how to build a really basic application, just a blog application. We showed you how to add indexes to improve the performance and how to use the explain mechanism to actually measure the performance of those queries and those indexes and make sure you were using your operations in the right way. And that brings us up to today, where we're going to talk about thinking in documents, right? And when we say documents, we mean JavaScript objects, right? Not PDFs or Word or the documents you'd print out and look at from a printer. These are JavaScript object notation. They're derived directly from the way that JavaScript thinks about and stores its objects. Within the database, we don't actually store straight up JSON. That would be horrendously inefficient to store, to parse, and to transmit over the wire. So they're actually encoded in a binary format, BSON, which is short for binary JSON. And so effectively we include type information and length information. So it makes it much more efficient to pull a document out and to parse it quickly. Otherwise, we would have to text parse all the sub-objects, and that would take an enormous amount of time. Every time you moved an object from one part of the system to the other, you need to reparse it. This is a full open source spec. It's defined at bsonspec.org, and I encourage you to take a look at it. For all intents and purposes, from a programmer's perspective, it's just JSON. Occasionally, the idea that it's binary JSON behind the scenes pops up. But our drivers, the application layers that the clients use, work really hard to make sure that you never really see BSON unless you want to. So it's more a case of that's what's happening over the wire, and that's what we store in the database itself. But from the programmer's perspective, it's JSON all the way down. And so what do we mean by JSON? Well, here's a JSON document. It looks just like JavaScript, except in the context of MongoDB, we understand that the first name is a string type. We understand that the cell number is actually an integer number. We understand that the geolocation is actually an array of 2 values. We understand that profession is an array of 3 strings. And we understand that there are sub-documents within the array cars that contain structure themselves. And so all of this information is typed and encoded in BSON so that we can efficiently retrieve documents, display them, and manipulate them without having to incur the overhead of reparsing all the text. Now, we know that documents can be stored in lots of different kinds of data stores, and I just wanted to show you what it means to be in one or other of these data stores. So if we keep our documents in a KeyValue store, well, we only get one key, right? And it's essentially the value, the index that you look up on. So if it's a shopping basket for an e-commerce application, it could be the basket ID or the username or some other unique key. But that's the only way we get to look at the data. And typically for KeyValue stores, it's done on a hashed basis, right? A hash key that very, very quickly gives you the value. However, you can't do any indexing on the value itself. So if, for instance, you wanted to find the total number of baskets with a value of over $100 in them, you'd have to scan all the keys in order to find all the values and actually pull the value out and then decide whether it's bigger or less than $100. We then have standard relational stores, and standard relational stores give us the ability to do what's called a tuple store, and we can store multiple values in each row, and of course we can index them by multiple keys. So we can store the key for column 1 or column 2 or column 3. We don't typically put an index on every column in a relational database because that would be very inefficient for write purposes, but we will make a judicious decision to pick which key to index on. The problem with relational data stores, of course, is you must fill in every value in the table, or if not, you must put in nulls there. And that's very poor for modeling the more diverse sorts of data sets that we see nowadays. Varying sets of strings, varying sets of text, hierarchical data. All of this is very challenging to model inside a data store that's relational because, of course, you have to fill in every value. And, of course, if I want to add a column to a data store that's relational, well, if I want to add a column between, any one of these columns, I've got to reload the whole database because of the way that we store data in relational databases. It's stored in row order. So, of course, each row has to be stored one after the other. So if we extend the size of any one row, we have to rewrite all the other rows. That means that you're getting into alter tables, and it takes a very long time. We've had customers that spend months doing this kind of thing. And now I'll take you to MongoDB. Now, MongoDB is a document store, so actually we can change the order and structure of the elements pretty much to map exactly what we see in the data that's coming into us, from the objects that we store, from the elements in the real world that we're trying to model. And this is a much more natural way of thinking about the world because we think in terms of hierarchy, and we think in terms of a thing being part of a thing that's a part of another thing. Object-oriented programming and polymorphism all base their approach and the fact that they're so easy to model in on the fact that we can model hierarchy really effectively and efficiently. So if we look at this, this is effectively saying I can choose again which keys I want to index on. And notice I can index down into the substructures of the JSON document. Again, I probably wouldn't create 7 indexes on a file like this because, of course, unless it was effectively a read-only database, every time you wrote a document, you would be writing 7 additional writes to update all the indexes. So although we have 7 candidate keys here, we may choose to only set up indexes on some of the keys, the ones that are most valuable. And if we look at how we model this in JSON or in BSON, we can see it's just effectively modeled in the hierarchy by essentially nesting the objects using curly brackets and using the JSON object notation. So I've just highlighted the keys here so you can see key 1 has a single value, but key 1 and the second document, notice this is a whole new document here. Key 1 and the second value has 2 entries in there. One of them has a single value, and the other one has a nested document here. So you see the nested document here? It has its own keys in there. And then again, we've got a third document down here, which again has 1 top-level key, and then another nested document with 2 sub-keys. And so you can see these would all be stored in the same collection. We would have a high-level index on key 1 that would be essentially consistent across the whole document. But we might have different indexes on the sub-documents depending on the number and cardinality of those documents and how many we expected to find in a collection. So let's just do some example queries. Well, if I want to find the first document, I just do db.test.find key1 value. This is assuming we're in the test collection here. Actually, it's meant to be demo collection. That's just a typo there. I didn't change it from the original testing I was doing. And that will find the first document, no problem, right? Because it matches on the key 1 value and it returns the whole document, which is value 1. Now, if we want to find the second document, we have to use this dot notation. And this dot notation effectively says reach down into the substructure of the document. So this dot notation here, you see, key1.key3.key4. That's effectively saying reach down into the document structure and find the value of key 4 that is equal to value 3. And of course, because there's only one document like that, what we'll see is it will return the second document. So we're effectively going from key 1 to key 2 or to key 3 to key 4 to get to this value. Just erase that. And then with the third one is we'll find the third document. We're just doing key1.key6. So we're just reaching again down between this key and this key to track value 5. And so that dot notation is something that turns out to be very useful for reaching into the structure. And of course, if these keys aren't indexed, then we'll do what any database does, which is we'll go and do a table scan of the database. And so one of the things I constantly remind people of when they're moving to NoSQL is don't turn your brain off when you turn on your first NoSQL database. You still need to define indexes to make your queries efficient. You still need usernames and passwords to secure your data. You still need to encrypt the database if you want to secure the data from prying eyes and keep the data file outside. So don't suddenly think that you don't need to pay any attention to the things you used to do with traditional databases when you turn on your NoSQL database. So what about modeling and cardinality? Well, think about the ways that we model things. Well, we've got the one-to-one model. So I've got a title, and each title has an associated blog post. There's only one title, and there's only one blog post. I'll show you how that's really straightforward to model. Then there's one-to-many. So for every blog post, we're going to have several comments. If you're TechCrunch, you're going to have hundreds of comments, maybe even thousands of comments per post. If you're the Huffington Post, it could be even worse. And then you've got the one-to-millions modeling. So if I'm looking at blog posts to site views, how many people looked at this particular blog post, how many people read past the first page, that can again go to millions and millions of entries for a very large, high-trafficked blog post site or website like Huffington Post. So how do we think about how we model these? Well, the one-to-one is easy. It's just an embedded document. So we embed the fields that we are associating with this document in the top level of the document. So title and body are essentially peer entries. So when I search for title, I'll always get the body back because it's one document that comes back in the result set. And if I search for the body, I'll return the document as well. And of course, with our full text indexing capabilities in MongoDB, we could index the whole text of this value here and search for body or text or very or short as individual words. So I could search for body or text, and that would return the whole document as well. So we can index on the whole field. So if I just put a normal index on body, I'd have to search for this is the body text of a very short post to return the value, or use a regular expression. If I do a text index, I can search on any word. So it gives us the ability to put these at the same level and search for them very efficiently. Now, one-to-many. Imagine I've got a blog, and it's my own blog that I run at home, and, guess what? I don't get that many comments. Well, a trivial way to do this is to embed the comments at the same level. And document and object embedding is a key property of MongoDB. Rather than the first leap of faith to be denormalizing your data, or rather I should say normalizing your data, where in a relational database you'd often, the first step is to break stuff up into different tables. Actually what we do in MongoDB is often, wherever we can, we try and bring objects together where they'll represent something like the real-world object. When I look at a blog post, I expect to see a title, a body, and some set of comments associated with it. Well, we want to model that in the same way. So here, what we're doing is we're building a title and a body, and then there's going to be an array. Notice the square bracket here. That means there's an array. And so within each array, we've got a sub-document. This is a sub-document. Right? You can see it just outlined there, the two curly brackets, and the same up here. This is another sub-document. So effectively, we're embedding the documents in the array. We put them inside an array to guarantee the order. And so I can use a very simple push to operator to add new comments to this array. And all I have to do is send the individual comment across the wire, and the server will add it to that list. So this gives us a way to very quickly build up a blog post in which we expect there to be a small number of comments. However, if the number of comments become large, imagine I suddenly become a more popular blog site. That's never going to happen, but you know, we live and dream. If I become a more popular blog site, then what I want to be able to do is handle lots of comments. And there's a couple of issues here with this then. First of all, you're adding lots of comments, but second of all, there's a finite limit to how big a document can be. We limit document sizes to 16 megabytes, which are pretty large. There's not too many things. I doubt there's too many Word documents on your hard disk that are 16 megabytes, unless they've got lots of images. But ultimately, if you continue to add comments to this list, at some point you're going to exceed the size of the document, and that will cause an error on the write. So think about a comment where we have maybe an image field to show a picture of the individual, or somebody starts writing very long comments, or there's lots of tags. We need a separate approach for this, right? We need to think about what we can do. How do we deal with the fact that comments can grow without bound? And so what are the key concerns? You know, we have to think about the write patterns. Comments are added more frequently than posts. That's just a matter of fact. There's way more comments on a blog than there is posts. And the comments may have images, tags, and large bodies of text. But the read patterns are different. We may choose not to display comments at all on the page of a blog post, and you have to go to a link to get to them. Or they may be shown in their own window as they're isolated. Or, you know, the real reality is people rarely look at comments. I love my friend's admonishment to me, don't look at the bottom half of the internet. You know, I would recommend to anybody to stay away from YouTube comments at all costs. So while the write patterns are fixed by the number of writers, the number of readers may change differently. So we can use that knowledge to account for how we build the schema. Right? So the trivial approach is, let's just go to a separate collection. So we're going to keep all the comments in a separate comments collection. And then we're going to add references to the comments as an array of comment IDs. So this requires now 2 queries to display the blog posts and associated comments. If, on the other hand, we decide to only display blog posts on our blog site, then we only need 1 query unless the person requests comments. So this isn't actually a bad idea. It does still require 2 writes to create comments because we have to update the original blog collection and then we have to write the comments collection. So we've split the screen here. So on the left-hand side, we've got the blog posts. We've still got our ID and our title and our body and our comments. But now our comments, notice, it's still an array, but it's an array of object IDs. And those object IDs are referring over here to these 2 objects here and here. So what we've got here now is a separate array of comments. One of the things that this gives us the advantage of is we can run analytics and we can run stats on the comments independent of the blog posts. On the other hand, we still have the challenge of object IDs are much smaller, but if you get millions of blog posts, you're still going to have an object ID issue here. How are we going to handle with this comment array? So there's a final approach we can take that deals with the exploding comment problem and gives us slightly better performance. And this is what we do, is we take each comment block, and it's not shown here, but effectively I limit the number of comments I'm embedding, but I embed the whole comment. So effectively now we can have up to 10 of these comments. So effectively the last 10 comments, or the first 10 comments if you prefer, on your blog are embedded in the post itself so they can be efficiently retrieved. They're still stored in the comment collection, but now each document is a batch of 10 comments. So each document has 10 comments in it. So when we retrieve a set of comments for a post, we don't have to retrieve them one at a time. We can get 10 at a time. And for most moderately trafficked blogs, 10 to 20 comments is what you'll expect to see. And of course, you could increase this for a high traffic blog. We can also make some assumptions here where we only store all of your comments for an associated blog post in one of these blocks. So now what we've got is we've got a collection in which we have all the comments for the first 10 comments linked with the object for the blog post, and then the rest of the comments stored in a separate collection, which is just all the comments, but each comment is part of a document containing 10 comments. That means we can pull the comments out more efficiently. Now, if we went for a more traditional SQL style approach, we'd store each comment as a single document, but often we want to deal with comments in batches, so storing them as 10 comments in a single document turns out to be a much more efficient way of doing this. And this is probably the way I would build it if I was going to design a generic blog platform like WordPress and I wasn't sure what the kind of traffic was going to be on any given blog. Because this will scale to thousands to millions of comments. It'll give me the performance I want, and I can run analytics on all of my comments in a separate table or a separate collection. So what about 1 to 1,000,000, right? How am I going to handle heat tracking or mouse tracking on a site, right? Each user is going to generate hundreds of data points per visit. That's thousands of data points per post and millions of data points per blog site. So now we reverse the model. So what we do now is we store a blog ID per event, and then we just put the post ID for the blog inside the event. So this is the blog ID here. And so for each blog that we keep a track of a post on, we just pop the ID in the event. And so we get lots of events. But that means now if we want to retrieve all the events that are associated with a particular blog post or with a particular time frame, we're doing lots of queries and returning lots of individual documents. And that in itself can be slightly inefficient. So now we go to a slightly different model, right? We know there's going to be a finite number of events per second that we're interested in. So now, for the post ID, we have a timestamp, which represents the time frame that we start tracking, and then we store the events essentially as a sequence inside a document, 0 to 59, right? That gives us the seconds for this particular timestamp of event. So this gives us the ability to store the next minute's worth of events. And then within a second, we can store a sub-second interview. So we divide the second into 100 parts. And now we can store info that occurs at each event. So if there's nobody on this blog post at all, you can have a minute go by and this whole thing would be nulled out. There'd be all effectively zeros in the info field. But if we, of course, see some events happening, then we can start dropping in the event, and it's just a set. And we can use that dot notation to go 0.52 and update the event in place. And that set function is very efficient in MongoDB to do. So now, instead of having an event or a document per event, we've got one document that can effectively store, over 600 events. And again, much more efficient to retrieve this document and pull it out. So, think about the general guidelines. For one-to-one capabilities, you want to embed objects. And think about embedding objects as your first point of departure, right? You want to look at the read and write patterns to decide when you might want to break out data or when you want to index something slightly differently from the main collection to the sub-collection. That's the point at which you might look at separating them out into 1 or 2 additional collections. In general, what we see when people migrate from a relational database to a non-relational, the number of tables is dramatically reduced. 10s to 20s of tables can reduce to 1 or 2 collections because that implicit denormalization you get from embedding objects means you start losing a lot of the joins and tables you've exploded. Don't get stuck in one record per item thinking. It's often more efficient to batch records together so that you're retrieving single documents. Again, look at the read and write patterns to work out when it's appropriate to do this and when you should batch up. Embrace your hierarchy. Think about the depth of the objects and the way in which they're represented in the code in your application. don't be afraid of just mapping that straight into your application for the purposes of modeling. Think about the cardinality. How many of these things are there going to be? Is it one to many, one to few, or one to millions? If the mapping is going to be large, it's a completely different issue when you're mapping all of the sensor data from 1,000 sensors or 10,000 sensors from a chemical plant than tracking the account records for employees in a moderately sized company. So cardinality is one of the things that controls whether you split up or whether you join and embed objects. Think about growing your data by adding documents, not by increasing document size. We absolutely have the capability to increase document size up to 16 megabytes, and we do that very efficiently in the WiredTiger storage engine, but it's probably the wrong design pattern for you. Think about growing your data by adding documents, where again, that's the most efficient operation we can do in MongoDB. Think about your indexes. The indexes will give you much more efficient queries, but there is a cost to indexes in that there's a write overhead for every index that you add to your collection. So one of the reasons you might partition a collection into 2 or more collections is essentially to isolate the write workload from one set of indexes to another set of indexes. And then your underlying documents, right? The updates to documents are transactional. People talk about NoSQL databases not being transactional. We don't do multi-document transactions. So you can't wrap several updates to several different documents in a begin transaction, end transaction. But within a single document, updates are serialized and guaranteed to be transactional. So if you've got 500 updates to a document, they'll be serialized by the database automatically. And we can use that device to understand how to control the updates to other parts of our system. That's pretty much it from today, from the presentation part of the session. We have time for about 25 minutes of questions. I'm going to take a look at the questions now and start answering them interactively. So Michael McDonald asks, are indexes by default full text indexes, or is that an individual option? No, by default they are fielded indexes based on the fields you specify. You have to ask explicitly for a text index, Michael. Neil Mullins, why not store the ID of the blog post in the comments? Well, we did move to doing that as we moved down the cycle, and you could just move completely to that and just do the lookup and then, but then it's quite long-winded to find all the comments associated with a blog unless you've indexed on that particular field. Venkata Fani Aburi, approach 3, hybrid approach. We need to get the design right first time in this case. Not necessarily. When you're building your blog, it's a lot easier to deal with one document than it is to deal with 2 collections. And so when you're building a basic content management system, if you're doing this for the first time, that's probably the right approach. It's simpler and easier to understand, and it's a more agile way of thinking about the world. When we start to scale out, then we can start thinking about how we handle the massive loads and the huge numbers of blog posts. But, you know, over-designing is one of the great challenges we face as modern developers. Designing for a future that we haven't yet met causes us to waste lots of time. Much better to meet that future when it arrives, because generally the future you expected isn't the one that you get. So I think it's more important that we simplify the design at the start and add complexity as the use case demands it. I guarantee you the places where you invest in guessing at the complexity of your future solution is the places where you'll waste time, and what you'll discover is the real challenges that you face are something completely different. I was building an online backup system a couple of years ago. We thought that backing up the files was the biggest challenge. Actually, the biggest challenge was generating the thumbnails for the images that we were backing up. That was computationally hard and was always lagging behind the rest of the backup systems that we were using. Nidyananantam says, how do we convert or redesign large tables from existing relational databases to MongoDB? Just converting the tables to flat documents to nullify that? Yes, this is correct. you need to think about how you're going to build a document model for your database. So think about what are the joins that you're doing in your existing relational application. There's an opportunity for embedding. What are the things, where is the main write load from your relational database? There's a place where you might look at either one or two collections. What are the existing indexes you're using, and can they be replaced by compound indexes in MongoDB? It's not an easy question to answer, I have to say, because one of the challenges we face is, of course, every schema and every relational database model is different, but always think about what's the end model you're getting for. What do you use currently to map from? When you're using an object relational mapping system, what do the objects look like? That's probably your starting point for where you're going to store data in a NoSQL database like MongoDB, because effectively you eliminate the need to do object relational mapping. Can you explain the hybrid approach again? I think the best thing to do there is watch the recording, and if you've still got questions, send them to backtobasics@mongodb.com. How documents greater than 16 megabytes are stored in MongoDB? What is the mechanism to store? Asks Sarav Agnihotri. So if you need to store larger binary objects, we have a capability called GridFS, which is well documented on our doc site. Effectively, GridFS allows you to store and stream large objects into MongoDB, and it partitions them into sub 16 megabyte chunks automatically. So if you look at GridFS and the GridFS documentation, it will explain how to do that. It's very straightforward, and it gives you the ability to store pretty much arbitrary sized binary objects. Filippo Todescini, are there some limit on the number of documents in a collection? Yes, it's the largest 64-bit integer you can store, which is a very big number. Benjamin Varese, what happens when the same document is updated in two shards at the same time? There is no way a document can be stored in two shards at the same time. One of the requirements for a sharded cluster is that the cluster is partitioned by a shard key that guarantees that each document is unique at the shard level. So if you're updating a document in shard 1, it can't exist in shard 2. That's one of the constraints on the system. Sarav Agnihotri says, is locking possible in MongoDB and at what level? It's document level locking, so when you effectively start to write to a document, it's implicitly locked. We don't offer the ability within the database to set locks at any other level, and if you want to do that, then you need to use an external locking mechanism to guarantee sequential access to the data. Sheriff O'Casey, I have about 5,000 plus text notes for each entity. Should I embed this in the main entry document? Each note can be up to 200 words long or more. I would say at that point you should look at something that's separate from the main collection, because those are large documents and it sounds like they might get bigger and you're in danger of exceeding the overall size limits of the database. So that's a case where when the documents and the sub-documents are that large, it may be a case for keeping it in a separate collection. Manash Singh Thakkar, is there any difference between SQL Server Index and MongoDB indexing? No, not really. They're both B-tree indexes, and I mean, lots of SQL databases use more exotic indexing techniques, but at the bottom, most of them use B-tree indexing, and that's exactly what we use as well. How to add security for access to document. Is it good to add roles in document or keep them separate, says Saravan Ramlagam. You can control access to the database based on a set of logins and a set of roles that you have, and the roles control how you access documents and how you access collections. So you can decide whether you can write to documents or read from documents. There isn't effectively what you'd think of as row-level access. You can't do row-level access controls to documents. You can use what we call a redaction framework to return queries where essentially based on the user, we can occlude or remove parts of a document that are being returned in a query. Madhavi, Tangarala, how do you control the second document you mentioned to store the comments? How do we name it and where do we store all the similar files? You just keep it in a separate collection. So you'd have named collections. So the first collection might be called blog posts and the second collection would be called comments. And you just insert the documents into that comments collection. Shailender Arya, in the example you gave, we don't need to have comments in the blog ID in the comments suffice, and we will be able to do all the operations. Yes, that is correct. How to find a collection with having a distinct key field. This is from Karthik Kumar Nagaraji. There is a distinct operator in MongoDB, and you can also set up indexes so that they'll be unique. And that means if you try and insert a key which has a value that is non-unique, the insert will fail. Can you explain how do we redesign the blog solution to include the blog views in the document? Venkata, I don't quite understand this question. Maybe you can drop me an email and we'll cover it afterwards. V. Srinivas Rao, standard steps to follow while designing MongoDB. We have a range of white papers on this, V. Srinivas, and what we can do is if you drop me an email afterwards, what we'll do is we'll send you a set of links to those white papers. Richard Franco, when is it recommended to use MongoDB instead of SQL databases? Is it recommended for solutions with few data? It works for, remember this is a big data database, but it's also designed to be a database that's very easy to program and use. So there's no object relational mapping. The data types that we store in the database are the data types you're going to be interacting with in your application. So we recommend you pick MongoDB when you have a need to develop in an agile fashion at great rate, and when you don't know ultimately what the final schema is going to look like. Or more importantly, even though you know what the final schema is going to look like, your first use with customers is going to change those requirements, and now you're going to need to change the schema. So our expectation is with modern agile and lean startup development approaches, we deliver something that works and that does something like 20% of what the customer wants, and we use that essentially straw man to get feedback. And in that situation, you need a database that's highly dynamic and can handle the idea that we're going to change the schema over time based on changing user requirements. And in that scenario, there's nothing better than MongoDB, Richard. Himna Shukarki, there was a scenario where you made two collections and stored comments in different collections. How do you maintain consistency between the two dependent documents? This is where MongoDB doesn't help you the way the SQL databases do by giving you foreign key access. We don't support foreign key references because it's one of the ways in which you can crystallize your schema and remove the ability to make it dynamic. So it's up to the application to ensure that both of those collections are kept consistent. If you were to put a foreign key constraint in there, and now you wanted to change the collection, imagine you wanted to move objects from one collection to another, well, your historical data couldn't be moved because guess what? It's tied down by that foreign key constraint. Foreign key constraints look great because they effectively crystallize your schema, but if your schema has to change, they turn out to be an absolute nightmare because, of course, they've enshrined what you used to do before, and when you want to change that schema, the foreign keys prevent that from happening. Sanchet Digny, if the read and write patterns change in the future, how complicated is it to refactor the document strategy? What are the most common refactor strategies that you follow suggest? Well, I talked about most of them today. We start with embedding, then we might unbundle some of those documents and take them into a different collection. We might change the indexes, or we might change the structure of the documents. And often what we find is parts of the application need a new structure and parts of the application want to use the old structure. That's perfectly acceptable. With dynamic schema, we can hold multiple schemas in the same collection. That means both the old and the new can coexist. And it also means when we're in transition, we can keep the old and the new in the same table. So it's not like a relational database where if I want to add a column, all the columns in the past get that new column. We can add fields to new documents to support new use cases, and the old documents and the old use cases can continue to use the old values. Could you please, Surya Arundhati, could you please clarify the difference between a column family and a document store? I'm not that familiar with column families. I know they're a concept within Cassandra, but a document store is essentially a set of collections, and those collections contain documents. So from a relational perspective, a collection is a table, and a document is effectively a row in that table. The way we differ from rows is that our documents can vary in size and can have hierarchical substructures. And those hierarchical substructures can be indexed, Surya. So it means you can reach down into the document. They seem to be a set of key value pairs with no schema. No, the schema is implied by the structure of the document and by the indexes that you impose on it. And also, with MongoDB 3.2, we have a thing called schema validation, which I haven't talked about today, which essentially says I can impose a schema substructure on a document that effectively says it must comply with this document's format before I can insert it into the database. Christopher Lerbat, could you explain why there is a need to concatenate the index keys when accessing a nested index since they are unique anyways? Well, they may not be unique. It's quite possible to reuse those names within the structures, and then you'd have to dot reference them. They were unique in the example, but they don't have to be. And the dotted notation allows you to reach right down into that value. Saurav Agnihotri, thanks. Is sharding possible for GridFS? Yes, absolutely, you can shard GridFS. Is there any way we can capture metadata to the tables and columns in it? What would be the best way to capture it? We don't have a data dictionary per se, but you can always capture that metadata yourself and put it in a separate collection. Arturo Chamorro, is there any possibility to relate two keys in two different documents that have the same value? Is there any possibility to relate two keys in two different documents that have the same value? You could do it in a separate collection, absolutely. Sushil Bansai, I want to generate ID based on max record and insert a record max +1. How to handle concurrent user to generate same ID? Sorry, Sushil, I don't really understand that question, but again, drop me an email afterwards and we'll try and get to the bottom of it. How the concurrent update of a single document is synchronized? That's what the database does, Saruv Kangdelwai. Apologies. That's what a database does. That's what the database storage engine, our Wired Tiger storage engine, is designed to ensure concurrent access. That's why a database exists, to give you that concurrency. Saravan Ramlingam, I am keeping user access details in embedded document. How can I do it? Just put it in the embedded document. I'd need to see your structure, but you can keep a user, and effectively you can store the user access details in an embedded document. If it's an overwrite model, you just overwrite them each time they're accessed. If you want to keep historical access, then we may reach a point where you exceed the 16 megabyte limit, in which case what you should do is move it to a separate collection. Josh Yaxley, how do you suggest storing many-to-many relationships? It depends on the many-to-many relationships. There are a lot of models for that. Again, we have some white papers on this, which I can get to you afterwards. Manesh Singh Thakur, what happens if an index does not fit in memory? Everything will run much, much slower. So one of the key things you've got to do for tuning your database, and again, this comes back to my don't turn your brain off when you turn on your NoSQL database. Yes, if everything fits in memory, if your working set fits in memory, things will run super fast. If your index particularly doesn't fit in memory, then you're going to see a massive degradation in performance. So one of your first challenges when you're building a model of your database is to ensure that the index will fit in memory, or a sufficient amount of the index to validate most of the working set queries. Sushant Gawali, can a view be created on documents from multiple collections? No, we cannot do that directly. There is a $lookup operator in our aggregation framework, which we'll be talking about in a subsequent webinar, which will effectively create a collection that represents the merge of content of documents from multiple collections. So it is possible to do it, but it's not like a view, it's not dynamic. It's effectively a point-in-time snapshot of the data. Aliakse Wojcik, how would you model bitemporal data with MongoDB? That's probably too complicated a topic for this particular webinar, Aliakse. Give me a shout afterwards and I will try and deal with that. Harish, who hasn't provided his second name, if we have post ID in one collection and its details like title, date, etc. in another collection, is there a way to query post details based on the post ID in one query instead of two queries? No, there isn't. You have to make two queries. That's the cost of a high-performance database like MongoDB. You get to make those choices for you. We don't have a join operator. The $lookup can do it in the aggregation framework context, but we don't have a generalized query for that. Elisa Gonzalez, hello, how could we store flat files in MongoDB? How can I afterwards retrieve the information? There are two ways to store flat files in MongoDB. If you know your flat files are going to be less than 16 megabytes in size, you can store them as a binary object inside a document. If you think they're going to be bigger than 16 megabytes, you can store them in gridfs, which will essentially slice and dice them into a set of blocks or subcomponents that are less than 16 megabytes. Navjot Sharma, question, NoSQL databases are more of dealing with data where we don't know columns prior to insertion, but then how schema designing helps, and does schema designing have any ROM impact here? We're not saying you don't have a schema. What we're saying is you've got dynamic schema. That means absolutely, for most applications, there's going to be a fixed schema. But the beauty of MongoDB is that schema can vary where you have exceptions, or it can vary where your requirements change. And the idea of document validation, which is a capability in 3.2, allows you to impose a certain level of schema discipline, but it still allows the area outside of that document validation coverage to vary. And I recommend you look at the document validation document or documentation for that. Nicholas Di Pietro, if you want to store a full tree or object, naturally you think about subdocuments and subdocuments of subdocuments. But at usage it seems to be difficult to retrieve sub-subdocuments. So after you think of more than one parent to many child and index the full path, if you want to create a second view. So I've done this. So what you can do is effectively you can store the same documents with a parent and child node pointing upwards and downwards, and you can walk that tree of documents very effectively. Again, there are some blog posts on this which we can look at afterwards, Nicholas. Madhavi Tangarala, what kind of things can we structure using schema validation that you mentioned is added in 3.2? Anything. So effectively your schema validation is a document that defines the structure of the documents you want to insert. And if your document matches that validation, the insert goes ahead. If it doesn't, then the insert will be rejected. You can also set up document validation to just do it on a warning, and you can also say it's just for new inserts that existing documents can be ignored. I recommend you look at the documentation. How many indexes can we create for the collection? There is a limit on the number of indexes for a collection. It's a massive number. I think it's like 65,000. I'll need to look that up for you, Prasad. Abjit Bhattacharya. Updates to single document is transactional, so how we set the isolation level to prevent dirty reads. Any read to any document is guaranteed to be strongly consistent, so you're not going to get dirty reads. That can't happen with MongoDB in 3.2. And there is a specific setting called a read preference which can guarantee that. Again, I recommend you look at the read preference documentation. Sarav Agnihotri, how is scattering and fragmentation handled in MongoDB? The WiredTiger storage engine has its own block disk manager that essentially manages scattering and fragmentation on disk, and it will endeavor to keep the data consistent, and it fills holes and it recompacts automatically. Prasad Nyalapatia, how many sub-documents can we create in a document? Again, there is a limit, but it's quite high. I'd need to look it up, but it's pretty substantial. Okay, I think that's all the questions for today, unless somebody throws one in. Somebody's just asked, Christopher Lerbat, could you explain why there is a need to concatenate the index keys when accessing an SD? Now, we talked about that one already. Let me see where we are on the questions. Pal Thingba, should you store binary objects like images in MongoDB? You can, and like I said, GridFS will allow you to do that. And one of the things that makes it convenient is, of course, you're storing the metadata and the object in the same location. That makes for a lot easier model for backing up, for restoring, and for indexing, and for searching and for retrieving. Using separate data stores, it's very easy to get the data inconsistent. So it makes life a little easier. Okay, folks, it's 10 minutes to the top of the hour. Rather than letting our fire drill inflict itself on your ears, I will say goodbye to everybody. Thank you so much for joining us today. I look forward to seeing you on webinar 4, which we'll be holding in a couple of weeks' time, and details will be going out via email. If you have any other questions, you can email me, joe.drumgoole@mongodb.com, and I'll endeavor to answer them as best I can. Thanks very much, folks. I'll see you at the next webinar.